Have you ever contemplated the enigmas that lie concealed within the vast expanse of the cosmos? The stars are not merely specks of light in the night sky. They contain an entire universe, comprising a multitude of strange, wondrous, and occasionally perplexing worlds. Beyond our own solar system, which is situated in the Milky Way galaxy, are planets that orbit other stars. These are known as exoplanets, and astronomers have discovered thousands of them in recent decades. The planets in this category exhibit a wide range of sizes, from the massive gas giants that are larger than Jupiter to the rocky worlds that are only slightly larger than Earth. However, not all types of planets are found in the locations one might expect. One of the most significant enigmas in exoplanet research is the phenomenon known as the Neptunian Desert, as described by astronomers. The region in question is one in which one would expect to find planets of a similar size to Neptune. However, there is a notable absence of such bodies. These absent worlds, designated as hot Neptunes, are scarce despite the assumption that they could flourish in such environments, similar to hot Jupiters. The question thus arises as to their whereabouts. The question thus arises as to why these worlds are not observed to be more numerous in proximity to their stars. A team of astronomers has finally made a breakthrough by combining years of data and observations. The team has identified a previously unrecognized feature in the distribution of exoplanets, which may provide insight into this enigma. The team has designated this phenomenon the Neptunian Ridge. It is a narrow boundary that separates two distinct regions of space. On one side is the Neptunian Desert, which is devoid of Neptune-sized planets. On the other side is the Neptunian Savanna, which contains a greater number of these worlds, but at a greater distance from their stars. This ridge represents a crucial point of interest. But what exactly is the Neptunian Ridge, and why does it matter? Let us proceed with a detailed examination of the subject matter. Firstly, it is essential to gain an understanding of the structure of this planetary landscape. As a result of extensive research, scientists have identified patterns in the characteristics of the thousands of exoplanets they have discovered. One of the most intriguing findings is the dearth of Neptune-sized planets, those with a mass and size comparable to that of Neptune in our solar system, orbiting in close proximity to their stars. Such planets are frequently designated hot Neptunes, and their dearth in this region has posed a vexing conundrum for astronomers for an extended period. To elucidate this phenomenon, it is necessary to delve into the domain of planetary science. Planets that orbit in close proximity to their stars are subjected to extreme conditions. The intense radiation from the host star can result in the loss of a planet's atmosphere through a process known as photoevaporation. The intense radiation from the host star erodes the gaseous envelopes of these planets over time. This could result in the reduction of a Neptune-sized planet to a smaller size, potentially down to the scale of a super-Earth or a rocky planet with minimal to no atmosphere. Consequently, the Neptunian Desert represents an area where Neptune-sized planets appear to be unable to survive. It is a region characterized by extreme conditions that either erode these planets or prevent their formation. However, the question remains, what lies on the other side of this desert? As one moves farther from the star, the circumstances undergo a transformation. Planets in this region are better protected from the destructive effects of stellar radiation. In this more distant region, which has been designated the Neptunian Savanna by astronomers, there are a greater number of planets with characteristics similar to those of Neptune that have been able to retain their atmospheres. The greater the distance between a planet and its star, the greater the protection from atmospheric destruction. However, the most intriguing aspect of this phenomenon is as follows. The newly discovered Neptunian Ridge is situated between these two regions. This critical zone serves as a transitional area between the Neptunian Desert and the Savanna. The Neptunian Ridge represents a transition zone where some Neptune-sized planets appear to persist for a sufficient duration to provide astronomers with valuable insights into the evolution of planetary systems. This ridge may prove to be a key to unlocking the secrets of planetary migration, defined as the process by which planets shift their orbits over time, often moving closer to or farther away from their stars. This discovery is significant because it helps explain not only why hot Neptunes are so rare, but also how planets can migrate inward toward their stars without being completely stripped of their atmospheres. The planets in this ridge are believed to be survivors, worlds that have managed to migrate inward, getting closer to their stars, but have not yet been eroded down to smaller sizes. They exist in a delicate balance, and studying them could reveal a great deal about the forces at play in shaping planetary systems. The initial identification of this ridge was made by astronomers utilizing data obtained from NASA's Kepler Space Telescope, which has been instrumental in the discovery of thousands of exoplanets. Upon analysis of the data, the team discovered a surprising overdensity of planets in this specific region. In other words, the concentration of planets in the Neptunian Ridge is higher than anticipated, indicating a significant transition between the arid, desolate Neptunian Desert and the more populated Neptunian Savanna. The Neptunian Ridge is not the only feature that merits attention. Furthermore, it is of great significance, as it may provide a crucial missing link in our understanding of how planets evolve under extreme conditions. The Neptunian Ridge offers astronomers a unique opportunity to study planetary systems that have migrated inward, moving closer to their stars after forming farther away. This migration, designated as high eccentricity migration, may elucidate the manner by which planets ultimately become situated within the Neptunian Ridge, thereby enabling us to gain insight into their evolutionary trajectory. High eccentricity migration is a process that typically occurs at the late stages of a planet's existence. It is hypothesized that this occurs when a planet's orbit becomes more elliptical, causing it to move closer to its star over time. For a Neptune-sized planet, this kind of migration could be dangerous. As the planet moves inward, it faces increasing levels of radiation that could strip away its atmosphere. However, the planets in the Neptunian Ridge seem to be resisting this process, at least for now. By studying these worlds, astronomers aim to gain a deeper understanding of how migration works and why some planets survive while others are destroyed. One might reasonably inquire as to why this is of consequence. What is the significance of this ridge, this transition zone between a desert and a savanna of planets? The answer can be found in the insights it offers into the evolution of planetary systems, both beyond and within our solar system. By elucidating the mechanisms and causes of planetary motion and transformation over time, we can gain greater insight into some of the most profound questions in astronomy, including the processes by which planets are formed. What determines the shape of their orbits? Furthermore, it is of great importance to ascertain the prevalence of planets similar to Earth. The discovery of the Neptunian Ridge represents merely the initial phase of a much larger undertaking. It facilitates the pursuit of new avenues of exploration, enabling astronomers to evaluate their hypotheses regarding the evolution of planetary systems under the influence of their host stars. With the aid of sophisticated instruments such as the Very Large Telescope, VLT, and its espresso apparatus, astronomers will be able to conduct detailed studies of these planets that will surpass previous efforts. One crucial piece of information that will be sought is the orientation of these planets. This is of great consequence for an understanding of the mechanics of migration, as the tilt and angle of a planet's orbit can reveal how it has been shaped by its environment. Upcoming observations with the VLT will assist astronomers in refining their models of planet migration, thereby providing a more detailed understanding of how planets move and evolve in the harsh conditions near their stars. By focusing on the rare hot Neptunes that exist in this ridge, researchers aim to test their hypotheses and uncover new insights into the life cycles of planets. However, there is still a considerable amount of information that remains unknown. The Neptunian Ridge represents merely one component of a much larger, interconnected system. As we continue to explore the universe, it is inevitable that our understanding of planetary systems and the forces that govern them will be reshaped by the discoveries that we make. As our knowledge of these distant worlds increases, it becomes increasingly evident that planetary systems can exhibit a remarkable diversity and dynamism. With each new discovery, we gain greater insight not only into the cosmos, but also into our own place within it. The forthcoming years promise to be a period of significant advancement in the field of exoplanet research. The advent of new telescopes and technologies will enable us to delve deeper into the universe, uncovering new planets and refining our models of how they form and evolve. The discovery of the Neptunian Ridge serves as a reminder that even in the vast expanse of space, there are still numerous secrets awaiting discovery. It is possible that the next significant discovery may bring us even closer to identifying planets that could potentially support life, or at the very least, provide insights into the conditions that facilitate the emergence of life. As we persist in our quest to understand the cosmos, one certainty emerges. The universe is far more intricate, enigmatic, and captivating than we could have ever imagined.